Okay, welcome back. And we need to continue to talk about blood. Now that we're more familiar with a blood sample, now we need to turn a different path and talk about how to identify blood or a sample that possibly could be blood. And we're going to talk about three of the most common ways that we can detect blood, whether it's in a room, on a wall, in a carpet, on a piece of fabric, like a piece of clothing. We're going to go through those common types of testing. Okay, so what you're going to find out is that blood identification really relies on chemistry. Go figure, right? And some of the chemistry you have been using for all of our program. You just didn't realize it at that point. But before I talk about the different types of tests, I want to talk about the different types of blood evidence. What are ways that we can get a blood sample maybe submitted to the lab, or some of the things that we need to focus on as far as blood goes? And what you're seeing on the screen right now are three different ways. One up at the top are blood samples. We know that they're blood, and we donate that blood to a laboratory and or give it to them, and we tell them, test it for us, please. The next one is blood droplets. So not an entire sample, but maybe something that we have collected, maybe on a crime scene, that we have submitted to a laboratory, and we want to know more about the drops. And then next is the blood spatter, or splatter. Some people use that term as well. And blood spatter is basically, if you get hit, how does the blood sling? Across the room, or down on the floor, or across someone's article of clothing. So the blood samples, they can be analyzed, all right? And we're going to do some of this stuff over the course of the semester. So up here at the top, the blood sample, we will have real blood samples in our lab that we will be handling, right? The whole purpose of this course is to get you familiar with the real stuff. We're not going to be playing pretend. They're not going to be fake blood samples that we're going to have. Well, where do we get those blood samples that we're going to play around with in our lab? They might come from you, believe it or not. And we've also contacted our phlebotomy program at Cape Fear Community College. And the phlebotomy program loves to give us some of their blood tubes that their students have to draw from each other for practice. So we will have real blood. We will let you know when you test real blood, so that way you can wear the appropriate gloves, you can throw away the samples the appropriate way into the biohazard containers and everything else. So we'll let you know when that time comes. Number two, blood droplets. They can be analyzed. And the blood droplets will also not only be blood typing, but we can actually utilize that and maybe extract DNA from it and do some DNA testing as well. So it gives us an idea of whose blood it was. If we have a victim, if we have a suspect, we can type the blood, see if it matches either or, and then we can extract DNA from that blood as well, and we'll talk about that in a different module. And the next is the blood spatter. And the blood spatter is basically, again, how does the blood sling across the room or onto an article of clothing if there is some type of force or if there's some type of movement, either from the victim or from the suspect. It gives us an idea of how this crime maybe has happened over the last day or so, whenever it did happen. Another thing that I want to say is, number one, just because it's red doesn't mean you're dead. What do I mean by that? Well, there's plenty of red things that happen in a laboratory. There's plenty of red things that happen in your home. And these are just maybe an assortment of different possibles that something red could be. Yes, it could be blood. And we probably have taken it to a laboratory because it's a very good indication that it is blood and we need to test it. But how can we make sure that it is blood? Just because it's red doesn't mean that it's an actual blood sample. Well, these are a couple of things that could be red. On a crime scene, on an article of clothing, on maybe a piece of carpet that has been brought into the lab that we need to test. And these are pretty common things like paint, some types of dyes, food coloring, pizza sauce, Kool-Aid, mud and clay, ketchup, beet juice, nail polish, and of course, red wine. So don't be surprised if we bring in something to a laboratory for you to test, and there'll be red things everywhere. And we'll say, are these blood samples? Are these blood droplets? Or is it something else instead? And we'll learn how to do that over a course of time. All right, so what makes blood different than all of these other things? It's actually not the color. The color's not what we're going to hone in on. Yeah, we know it's red. Everything else is reddish too. That means they maybe have something in common. There's a compound that gives us that red color, right? So we don't want to play off of that red coloring. What we do want to play off of is, what does blood have that these samples do not? And what blood has is a protein. And that protein is called hemoglobin. And what you're seeing on your screen right now to the right-hand side is the molecule of hemoglobin. Notice there's no carbons, there's no hydrogens, there's no skeletal structures or anything. That's because there's way too much. When we start talking about protein chemistry, or when we start talking about DNA, we're talking about macromolecules. Macro, M-A-C-R-O. That means it's big enough to see sometimes. These things are huge. And what you're seeing over here are these little curly cues. Those are basically chains of molecules, and those chains of molecules are wrapping themselves into a form that begins to take this helix structure. We also have these things called beta sheets, and if you look up here at the very top, you're going to see kind of a flat area of a molecule. And that perfectly flat, right, it's not curly Q here, but that perfectly flat area there is what we would call a beta sheet. I also see one down here toward the bottom, kind of on the opposite side, right? That is a beta sheet right there. It's not a full curly Q like a curly fry. That's what we call an alpha helix and beta sheets. Beta sheets are the flat, alpha helix are the curls. So this thing is swimming around in our blood. This thing is huge. Red wine probably doesn't have this thing in it, right? Paint probably doesn't have this in it. But your blood does. So what's the purpose of hemoglobin? Well, heme, H-E-M-E, or O, right up there at the top, you're going to see heme show up in a laboratory quite a bit. And heme is a prefix that is used for iron, Fe. So here on the left-hand side, you're going to see a picture of a red blood cell. And we now know that we can type the red blood cell based on the various proteins that are stuck to the outside surface. And keep in mind, these proteins, you know, there's 40, 50 other proteins that could be there that have been identified. We just don't pay attention to those because they're not drastically important like the A and the B are, and the rhesus. So in this red blood cell, they're showing you a component. And that component that we want to focus on is the hemoglobin. All right, hemoglobin is this conglomerate of these four pieces that are different colors in this picture. You see this orangey color, and you see the greenish color, you see the pinkish, and you also see the purplish. Notice they've labeled some of these: a beta chain, an alpha chain, a beta chain, an alpha chain. They're kind of letting you know some of the important pieces. We're not going to focus on those, but we are going to focus on something else that they've labeled. And this is the iron, Fe. And notice where they put it. They put like one here. You see it sandwiched in there with a little red ball on it, right? And it looks like they've put another one here. And it looks like another one here. And it looks like another one back here. So each glob, each piece or quadrant of the hemoglobin protein carries with it one iron, Fe. And iron's pretty important. It's going to make your body do a specific job. And iron is going to help transport oxygen to where it needs to go. So chemists long ago, and people that worked in the laboratory long ago, said to themselves, hey, listen, blood is a little different than some of these other red colors that are pretty common in a household. One of the ways that blood is different is the hemoglobin molecule. Because if I look at these samples like paint, dye, food coloring, pizza sauce, Kool-Aid, they're not going to have hemoglobin. So if we can play off of the hemoglobin molecule, and that in particular means the iron that's associated with it, then maybe, just maybe, we could do a very quick test to see if something is possibly blood. All right, so possibly is a key word here. Possibly means I'm going to test it. It could test positive, but I'm not going to guarantee that it's blood. I'm going to say that it tested positive for blood. But that doesn't guarantee me that that sample is actually blood, because we're going to have some interferences here, right? We're going to have some things out there that give me a positive read, but those samples might not be blood at all. They just react with the reaction in a similar way that blood does. We call these presumptive tests. So there is a presumptive test for blood, and we can do this test, and if it turns positive, we can say it reacted positively to the blood test that we did. I'm not going to guarantee that it's blood, but this is one clue that maybe we can do multiple clues, but this is just one of them that leads us to believe that it is a blood sample. So in the next video, what I'm going to do is I'm going to tell you about some of these tests. Some of these are very easy. Anybody can do them. I can get a 5-year-old to do some of these. So I know I can get you to do some of them. Not difficult at hard. So in the next video, we're going to talk about mainly 3 different tests. And then I'm going to pull some outside YouTube videos because I think some of these are pretty good. They are filmed by forensic chemists, and they are working in their laboratory, and they're kind of showing you what they're doing with real samples. And I think that's good for you. So it's going to be a mix of both me and external resources as well. You probably enjoy that. You don't want to listen to me gab all the time, right? Okay, so in the next video, we'll come back and we'll talk about our first test.